everyone. I'm Maaz. I'm excited today from the city right next door, which is called Geneva, to talk to you about looking at natural disasters from space. Here at Geospatial, we're trying to make geospatial data analysis. We're right next door at the EPFL Innovation Park, so come say hi if you want. This is the country of Bangladesh. It's a country that's 3 times more the size of Switzerland. There's a lot of water in this country. There are a lot of rivers, and it rains a lot. And when it does rain a lot, floods happen, and those floods are quite devastating. One such occurrence happened in 2022, where a flood affected 7.2 million people. Just to give you an idea, in Switzerland, we're about 8.6 million. And this flood affected more children, women, and seniors. Those affected schools, hospitals. More generally, a lot of buildings were destroyed. And to respond to such disasters, we of course use, like the colleagues earlier said, the geospatial technology, which is basically a way to leverage geographic information, location data, imagery, and other forms of AI to find relationships and insights between them. In this case, geospatial data analysis was used for real-time situation awareness, as well as location intelligence. Some challenges exist with the current state-of-the-art Earth observation aided response. The main one is the time it takes. They took a week here to make the complete analysis, some of the big agencies that worked on that, and to provide support despite the data being available. Secondly, the analysis did not take into account the essential infrastructure, such as hospital, roads, and power plants. And because geospatial data analysis is an expensive and time-consuming process, the smaller events are not really analyzed, only the big ones are done. The fourth argument is that the local experts do not have access to some of those tools, and usually they have to wait till the data comes out from those agencies to start working on those. So how do we actually propose to solve some of them? Well, we're trying to do this with geospatial AI, which is assisted by a generative AI chatbot, where a large language model is fine-tuned into a geospatial large language model, and natural language is translated into a sequence of different geoprocessing operations, which at the end of the day form a solution graph, and the user is the ultimate master of it and validates that. We're also looking at a web-hosted cloud solution that supports a scalable infrastructure and server-side processing operations in high speed, and this is all done remotely on Switzerland, so people out there in the field are also able to use some of those solutions. And at the end, we use data fusion, of course, to combine various data sets in order to get as much insights as possible for those. And it's basically, we call it a way for data to speak to each other. We've tried it with a pilot on the ChatGPT story. It was just an idea to see if actually we could try it out. And we tried it with some building estimations, see if text could actually make some geospatial analysis, just the basic operations. And we gathered quite some users, about 1,000 users in the launch month. And then we completely stopped this idea, and because it was quite successful. Some of those requests here are user-made. And as you can see, some of our users have been having fun playing around with population data, vegetation, looking at polygons, or even building footprints. And this means that we are now moving towards another type of solution, which is a bit more scalable, based on what the users are asking. And here is a web platform which is assisted by near real-time data and a geospatial language model. And this is putting some emphasis on near real-time data, and of course Earth observation coupled with worldwide geographical location data, such as roads or railways available on the world scale. Such as the case here. This is just a prototype UI with the chatbot interface on the right, and then on the left, a more geocentric interface. Here's a 30-second video. The user here is trying to write down to find an administrative division in Bangladesh. The solution then looks at this administrative division, gives the amount of people that live there based on an open data set. Here, there's about 4.4 million people that live in this area. You can put the flood extent on top of it, and by doing a simple geospatial operation, geoprocessing operation, you're able to estimate how many people are within this flood extent area. So just a very simple trial that was done by the team.
And now we're really looking at near real-time data. So of course, those open satellite images such as Sentinel, Landsat, and MODIS, and even more. And we're able to request the chatbot for those type of layers, and then put some buildings, power lines, roads, and such, and make some simple geoprocessing operations to get how many buildings were affected, what road was affected, or which power line was affected. And this we get it quite fast in a matter of, I would say, 10 seconds, which if the data is available, of course. There's multiple sources that we play around with, not only optical. We're looking at radar and thermal as well. As such, at the same area of interest, we're looking at radar satellite imagery, which is able, of course, to penetrate through clouds and look at water, and even during a rainy period. And the advantage of this is that it's if you combine it with optical, you get a very higher temporal resolution. Not only flooding, we're also looking at wildfires and earthquakes. Of course, the colleague earlier spoke about building damage assessments. We're definitely looking into that as well by using some of those open algorithms already available. Well, who are we doing this with? Mostly for any person that's data specialist and data friendly. If you're able to use an Excel spreadsheet, our vision is that you will be able to try some of this stuff out. And we're also doing this for authorities. We are grateful to be working with some of those partners here in Switzerland, as well as first responders, but also insurance and actuaries, as well as engineering firms. What do those people actually get? They get time saved. We've measured the building footprints, for example, and usually you do the analysis in about 3 hours. Now you're able to do it in a matter of seconds. We also try to lower those costs as it's less resource intensive and automated. You also get more insights, which includes near real-time Earth observation rate data, and as well as a higher accessibility with a friendly UI. What does the current research say? Well, it says that geospatial operations can be done in a limited manner with the current language models. We can also fine-tune an existing language model and teach it geospatial operations. This model can learn and interpret data operations and be in a successive operations. And at the end, geo-language models are not restricted to only vector or data imagery, but actually learn from computer vision. So let's together make some difference and make geospatial data speak to us. Thank you.